NAP, because I didn't record. Okay, now we're good. All right, so I'm going to go over this first 4 questions, and these were like the first 4 questions on the quiz, where it asked you to determine whether they were mutually exclusive, inclusive, dependent, or independent, okay? So first thing you want to read here, and I want to really differentiate this for you guys, because the real question is it an or question or an and question? So if it's an or question, it's going to be either mutually exclusive or inclusive, okay? If it's an and question, it's going to be dependent or independent, okay? So that's one of the keys that you guys really need to dial into. So with number 1 and number 2 here, notice it says find A or G. Here it says find E or vowel. And remember that that U means or, whereas the what I would call an A, we could make this an A, right? Couldn't you just put a slash right there and make that an A? That's a really easy way to remember, y'all, which one is and which one is or. The A looks like an A if you put a line right there, whereas the U is the or, okay? So or statements are always going to be mutually exclusive or inclusive. So that's really, really important that y'all catch that detail, okay? And then all we need to do is, and statements are always going to be dependent or independent, okay? So what does the mutually exclusive? Inclusive means, mutually exclusive means there's no overlap in the sets of information, okay? Inclusive means there is overlap in the sets of information. So let's look at 1 and 2. So first of all, it says here, you randomly choose a tile from the bag, find the probability that's an A or a G. Well, is there any relationship between A and G? I would say no, there's no overlap, okay? So I'm gonna type here, there's no overlap, okay? And what that tells me is that this is a mutually exclusive event, okay? Because there is no overlap, there's no relationship between an A or a G, okay? If I could type it would be good, okay? So then that means that when we talk about this, this is an or statement, so it's mutually exclusive, okay? That's all you had to do. Then it said, find the probability, right? Well, we didn't have to even do that on the quiz, you were just telling me what they were, okay? So I'm not even gonna go into that here, we'll go into that a little more later, okay? So let's talk about number 2. It says, you randomly chose a tile from the bag. What is the probability you chose an E or a vowel? Okay. Now, is there a relationship between E and vowel? Somebody unmute your mic and tell me, what is the relationship between E and a vowel? Somebody, anybody? Unmute your mic and tell me, is there a relationship between E and a vowel? Can anybody unmute your mic and tell me? Somebody, anybody?
Yeah.
What is the relationship between E and a vowel? Come on, somebody tell me, what is the relationship between E and a vowel? There you go. I heard someone say it. I heard someone start to say it. E is a vowel, isn't it, y'all? So that means there's an overlap between the group that is E, which is one thing, right? And vowel. So that's what tells me that this event, there's an overlap then, right? So that's what we're going to write. There's an overlap. So this one is inclusive, okay? And it's inclusive again because there's overlap in those two groups, because E is a vowel, okay? Does everybody understand that? Give me some feedback in the chat. Do you guys understand why it is inclusive? Because E is a vowel. Now, if we had put L there, then there would have been no overlap, right? Just like in the number 1, there was no overlap because there's no relationship between the A and the G. Y'all got me? All right, now we're down here on number 3. It says you randomly chose a tile from the bag, replace it, then choose another tile. Okay, what is the probability you chose A, then a consonant? Okay, or I'm sorry, B and a consonant. Okay, so this is an and statement, all right? Now, when it's and statements, y'all, that's when we're going to have independent or dependent. So got to get this in your brains. When it's or statements, that's when it's mutually exclusive or inclusive. When it's and statements, that's when it's going to be dependent and independent. So y'all need to write that down somewhere. You need to use that piece of information when y'all are taking the quiz again. And when you're taking the test, remember that. That's really key information, okay? So then on this one, it says you randomly choose a tile from the bag, replace it, then choose another tile. So this is my question for y'all. If we count up here, we had 1, 2, 3, 4, 5, 6, 7 letters, right, in algebra. So we had 7 letters in the bag, right, y'all? So I'm going to write that down here. We have 7 letters in the bag. Or however we have it. Yeah, bag. So it says in this problem that we take the tile, we pull a tile, and then we replace it. So did the number of tiles change in the bag if we took one and then put it back? Give me some responses here. Yeah, no, yes, no. Christian said yes, no. I think that second question was no. Wait a minute. Is he right, y'all? So yeah, he's right. So when I take a tile from the bag and then I put it back, it doesn't change the number. I still have 7 in the bag, don't I, y'all? Okay, so here's what we want to do. So because I put that letter back, this is going to be an independent. So what is the key to this? It's that we replaced it. So when we replace, we put it back, we return it. Those are the words we're looking for, y'all. When any of those things happen, that's when we can say that this is an independent event. Okay? Does everybody understand? It's an independent event because we put it back, we replaced it, we returned it. Those are the words you all want to look for, okay? Replace, return, put back, something of that nature. All right, so now let's look at number 4 down here. Again, now we know that this is going to be independent or dependent because, again, it says you randomly choose a tile from the bag, you do not replace it, and then randomly choose a second tile. What is the probability you choose an L and then a vowel? Are these events independent or dependent? So let's talk about this again. We again had 7 letters in the bag, right? 7 letters. We started out with 7 letters in the bag, but this time we didn't replace it. Y'all notice these words right here. We did not replace it. So if we took one out, do we still have 7 letters in the bag? Come on, give me some responses here. No. Right? So we don't have, so this time when we took that, so it says we do not replace, right? So what does that mean? Now we have 6 in the bag, right? That's what tells us this is a dependent. This is a dependent event, y'all, okay? That's what tells us this is a dependent event, okay? So do y'all have any questions about 1 through 4 at this point? Hopefully this is clarifying things for you guys about when it's mutually exclusive and inclusive, when it's dependent and independent. Remember, with or statements, that's when it's mutually exclusive or inclusive, and if there's overlap, that's when it's inclusive. When it's and statements, that's when it's dependent or independent. And when it's dependent, that means we took something out. We didn't return it. It didn't go back into the group we started with, okay? That could mean we destroyed it, we ate it, we kept it, we didn't replace it like it said in this problem. So just be looking for those kinds of words when you guys are dealing with trying to determine whether something's dependent or independent, okay? All right, so now, go ahead.
Are you going to post this video too?
I am. I will, for sure.
Okay.
All right, so then I'm just going to talk you through some of these, okay? So it says you draw a card from a bag that contains 4 yellow cards, number 1 through 4, and then 4 blue cards, number 1 through 4. Tell whether the events are mutually exclusive or inclusive. Now, I got a question for y'all, first of all. When you look at 2 sets of cards that have the same numbers on them, what kind of events do you think that that's going to create? Think about this. Michael, you need to unmute your mic and tell me what you mean by that question, because I don't understand the way you wrote it. Explain it to me. Michael's asking us a question, y'all. So, Michael, can you unmute your mic? Okay, well, if you're not going to unmute your mic, Michael, I can't help you. Okay, so let's just talk about this one for right now, because then we're going to talk about dependent and independent. We're going to look at 7 and 8 first. So it says you chose a yellow card and you chose a blue card. Why do I know this is an or statement? Y'all see this right here? That symbol right there means or. Do y'all see that? I just made it red. That means or. And it, so this is an or statement, so I know we're talking about mutually exclusive or inclusive. It says you chose a yellow card or you chose a blue card, okay? So here's my question. What is the probability that I choose a yellow card, y'all? First of all, how many cards are there total? Somebody respond to me there. How many cards are there total?
8.
Yes, there are 8 cards. So that's always going to be our denominator, y'all. So then we're talking about how many of those 8 cards were yellow cards. So someone tell me that. How many of the 8 cards were yellow cards?
4.
So we're going to do 4 over 8, right? Then we're going to add to it the number of blue cards. So how many of them were blue, y'all?
4.
4 over 8, right? So now, question. Was there any overlap in the blue and the yellow cards?
No.
Okay, so this time it's mutually exclusive. Do y'all see that? This is a mutually exclusive event because there's no overlap. Now, if we started talking about numbers, y'all, then we would have overlap, but we don't have overlap here. So this is really 8 over 8, which is what, y'all? 1, which is 100%. Does everybody see that? Does everybody see that? Make sense? Okay, so now let's talk about this other event down here, the event number 8. Okay, this time it says you choose a blue card. How many of the 8 cards are blue, y'all?
4.
Okay, so here again, we're going to do 4 over 8, right? And we're going to add to it the number of 3 cards. How many 3 cards do we have total?
2.
2 of them, because we have 1 3 card that's yellow and we have 1 3 card that's blue, right, y'all? So this is going to be our 2 over 8, right? Now, I got a question for you. Are there any of the cards that are both blue and a number 3?
Yes.
How many cards are both blue and a number 3?
1.
1 of them. Okay, so that means that's what we're going to subtract. Now, let me tell y'all why we have to subtract that. Right now, that 1 card is represented in the blue card, or the blue card's right here, and it's represented in the 3. So it's overrepresented. It's in both groups. And we can't count it twice. We can only count it once because it's 1 card, okay? So that means what we're going to do is do 4 over 8 plus 2 over 8. That would be 6 over 8. And we're going to subtract from it the 1. So that's going to give us, our probability is going to be 5 over 8. Does everybody see that? And if we were to turn that into a percentage, 5 divided by 8 is, let's go ahead and talk about what that is. It's 0.625. And then that as a percent, we just move the decimal place 2 places to the right. Okay? So that's going to be 62.5%. And y'all noticed on the quiz, the answers were represented all 3 different ways, right? Sometimes it's represented as a fraction. Sometimes it's represented as a decimal. Sometimes it's represented as a percentage. Does everybody know how to get from one to the other?
Yes.
Okay, so if not, you need to ask me a question now, okay? So now we're going to talk about this next set of questions, number 9, okay? So on number 9, it says, tell whether the events A and B are dependent or independent. Now, again, why do I know that I'm talking about dependent and independent? Because this is an and statement. And remember, I told you all that symbol right there looks like an A. If I put a line through the middle of it, it's going to look like a capital A, isn't it? That's the way to keep it straight in your mind, okay? So then it says a bag contains 3 red balls and 4 green balls. You randomly draw 1 ball. Do y'all see the key word? Somebody type into me, what is the key word? We're coming on it right now. What's the key
Replace it.
phrase? Replace it. Do y'all see this right here? That is really important because that tells me whether this is dependent or independent, okay? And randomly draws a second ball. Okay, so how many total balls do we have, y'all?
7.
49.
Huh? How many total balls? What's 3 plus 4, y'all?
7.
7, right? So don't we have a total of 7 balls, okay? So let's talk about whether this is going to be dependent or independent. So remember up here when we talked about this before, we talked about what's happening, did we replace it or not? And so we start out with 7 balls, right? We got 7 balls. And if it says we randomly draw 1 and replace it, are the number of balls in the bag going to change, y'all, for our next draw?
No.
Okay, so that means still 7 balls. when we draw our second ball, right, y'all? So that means this is independent. Why? Because of that word replace. Y'all see? It says replace it. So this is going to be independent. Okay? Then we're going to actually work this one. It says 3 balls are red, 4 balls are green. So we got a total of, we said 7 balls, right? So what's the probability that the first ball is red? How many balls are red, y'all?
3.
Come on, tell me.
3.
I had somebody put 4. What?
3.
How many balls are red? There's only 3 balls that are red. 3 over 7, right? Okay, now remember, this is an and statement. What do we do with and statements, y'all? Do we add or do we multiply? That's one of the differences.
Multiply.
We multiply. So that's another thing that you guys got to keep straight in your head is when we're dealing with and statements, we're not adding or subtracting. We are multiplying, okay? Really, really key piece of information, okay? So then it says we're going to replace it. So how many balls do we still have in the bag?
7.
Okay, so if it doesn't say, someone wrote in the chat, it didn't say replace. That means it's probably not. It was an or statement, not an and statement. So you guys got to watch for that. Okay, if it doesn't say replace or I ate it or I kept it or something like that, then it's probably an or statement, y'all, and you're looking for overlap. Okay, so just pay attention to that when you guys are taking the quiz. All right, so on this one, it says the second ball is red. So how many red balls are left in the bag if I put everything back, y'all?
3.
3. And how many total balls are left in the bag?
7.
So we're just going to do 3 over 7 again, right? So does everybody know how to do this? We multiply across the top, right? What is 3 times 3?
9.
And what is 7 times 7?
49.
Okay, so this is going to be 9 over 49. Now, on the quiz, guys, there would not be an answer represented like that. Why? What can we do with that number right there?
Reduce it.
Yeah, because 9 goes into 49, right? So this answer, if it was in fraction form, would be 1 over 9 because 9 goes into 49 9 times, right? And then if we were to figure out what it was as a decimal, when I divide 1 by 9, we get 0.11. And if we were to turn that into a percentage, it would be 11%. Does everybody understand? Any
Yes.
questions? Okay, so let's go down here to the second one, number 10, okay? So on this one, it says you write each of the letters of the word brightness on a piece of paper, place them in a bag. You randomly draw one letter, replace it, then randomly draw another one. So question, is this one going to be dependent or independent? If we're replacing it, y'all, is it going to be dependent or independent?
Independent.
It's going to be independent. So let's just change this problem. This wasn't what was on y'all's review, but we're going to change it just so we can talk about it. So we're going to say we kept it. Okay, I'm going to change these words right here to kept. Okay, y'all see that? I kept it this time. So now when we start talking about this problem, it's going to be a little bit different. Y'all understand? So again, what do we have to do first? We got to count how many letters are in the word brightness. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 letters. That's always going to be our denominator, y'all. So this time we're starting with 10 letters, right? So we got 10 letters. Be great if I could type. Okay. And this time we're keeping it. We're changing the way it was on y'all's original view to keep, okay? So what's going to happen every time I keep a letter out of the bag, y'all? What's going to happen the next time I pull a letter? Someone tell me.
It's going to get smaller.
Yeah, it's going to get smaller. So I start out with 10. If I keep one, the next time I pull one, there's only 9, and so on. Are y'all with me here? Okay, so let's talk about, so we kept it. So that means this one's going to be dependent, okay? Again, remember, this wasn't the original problem that was on y'all's review, but we're just using this one as an example. All right, so let's talk now about, we're looking for the letter B. How many letter B's do we have in the word brightness, y'all?
1.
Okay, so there's 1 out of 10, right, that were B's, okay? Now, again, this is a and question, y'all. So we're looking for the probability that it was, the first letter was a B and the second letter was an H, okay? So if that's the case, then what are we going to do with our, what is the operation? Are we adding? Are we multiplying? What are we doing, y'all? Multiplying, exactly. So we're going to do that again. I'm going to go up here and insert my multiplication symbol. Okay, so then we need to talk now. It says the second letter is a H. How many H's are there in the word brightness, guys?
1,
Okay, but we kept the B. So how many letters are there left in the bag?
9,
9. So yes, this is going to be 1. So this time we're going to multiply it by 1 over 9, aren't we? So once again, we're multiplying across the top. So that's going to be 1 times 1, which we know is 1. And then what is 9 times 10, y'all? Or 10 times 9? That's 90, right? Whoops, forgot my, there we go. So once again, if we were to turn this into a decimal, 1 divided by 90 is going to be 0.011, right? And if we were to talk about this as a percentage, remember again, we're moving the decimal place 2 places to the right, okay? So this is going to be 1.1%, okay? Any questions on that one? All right, now I want to go down here to the bottom of this and talk about these, because these are some other questions that you guys had difficulty with, okay? So it says, in a survey, 30 students were asked to pick 1 or 2 of their favorite colors from a list of 3. Use the Venn diagram to answer the following questions if a student is chosen at random. It says, what is the combination of colors that were not chosen by any student? Well, we got orange and blue here. See the overlap. We've got blue and pink here. There's overlap, but we don't have any overlap with the orange and the pink. So there would be, if we were to answer that question, it would be orange and pink here. Y'all with me? Okay, but we're going to focus more on the next 2 questions. And I got a couple other examples I want to talk to y'all about too. So this would be orange and pink. Okay, so now let's talk about this one. It says, find the probability that it was orange or blue. Now, there's a simple way to do this, and there's a more complicated way to do this, okay? So we're going to talk about both. The easy way for orange and blue is literally to count all of the numbers that are in the orange and blue circles, add them together, and put them over the total. Okay, so everybody listen. So that would be 6 plus 5 plus 12 plus 2. Does everybody see that? So what we would do is go 6 plus 5 plus 12 plus 2. Those are all the numbers that were in both circles. And then we would put that number over the total, which is up here. See this 30 up here, y'all? That is the number of total we had, right? So when we do that, 6 plus 5 plus 12 plus 2. So that's going to be 25, right? So that's 25 divided by 30, which if we reduce that, both of those are divisible by 5, right? So that would be 5 divided by 6. Again, your answer might be represented that way, remember. And then if we take it and put it into a decimal form, it's going to be 0.83. Oops, sorry. Equals 0.83, right? And then if we change that into a percentage, it's going to be, it was 833, y'all. So this is going to be 83.3%, okay? So that's the easy way. Now, what's the harder way? The harder way is to, and I don't know if I'd say harder, but it just depends on what the drawing looks like. So we could take all of these values that are in this circle. That would be 11, right? Because 6 plus 5 is 11 over 30. We're going to add to it the other circle. So this circle over here, how many does it have in it, y'all? The blue circle. How many are in that whole circle? Don't we have to add 12 to 5 to 2? So that's 14 plus 5, that's 19, right? Okay, now here's the challenge. We have some overlap in those 2 circles, don't we? This 5 right here is the overlap. Well, right now we have it counted twice, so we have to subtract it. This is going to be an inclusive problem, y'all. So we're going to subtract the 5 over the 30. And when we do this, this right here would have been 30, right? Minus 5, that's still our 25 over 30. Do y'all see that? So no matter which way you do it, you're going to get the same answer, okay? And it really depends on the drawing, but the drawing on y'all's quiz looked a lot like the one that's there. So then let's talk about blue and pink. This one to me is even easier because this one, we're not going to multiply anything. We're just looking for the overlap when it's blue and pink. So we literally can just take this number right here. Y'all see this number? Whoops. This number 2 right here, because we're talking about what's in the blue circle and what's in the pink circle. We can just take the overlap right there and put it over the total. So that's just 2 over 30, right? Which is 1 over 15. Again, if we change that into a decimal, we divide 1 by 15. That's going to be 0.066, which is 6.7%. Any questions on that one? No? Yes? Maybe so? All right, so I want to show y'all one that looks like the quiz, okay? Because it had 3 on it, right? So, because we only have a few minutes left. So let's just talk about this one. It says, of 300 surveyed, 98 people voted to change the school colors, 68 voted to change the school colors and the mascot, 76 voted to change the school mascot, 72 voted to change the song, and 5 voted to change all 3. Now, this is a little bit different than the problem y'all had on your review because I added another circle. Well, I did this on purpose. So let's just talk about some different ways that the different questions we could be asked. So we could be asked, what is the probability that someone wanted to change the colors or, which I'm going to put the or symbol up here, y'all. Or is that symbol, right? Colors or, what do y'all want? Mascot or song? Someone to give me what you want.
Song.
Song. Okay, so what if we wanted to change the mascot or the song? Okay, so what does that look like? So everybody listen. I'm going to show y'all. So this is going to be that question where we're looking for how many are in the color circle here. So how many are in the color circle? Tell me how many total are in the color circle, y'all. What do we have to do to get that? Can anyone tell me how to do this?
Add them.
So don't we have to add the 35 to the 58 to the 28 to the 5? Do y'all see that? That's how many are in the color circle. Y'all with me here? We're going to put that over our total. What was the total number of people that were surveyed up here, y'all? 300, right? Y'all see that? Okay, now, if we're trying to find color or song, okay, then we can add up all the people that were in this song one, right? So, and let me put that in parentheses because that's one term, y'all. So that's all one term, right? Then I'm going to add to it how many were in the song one. So how many were in the song? So we had 10 plus our 31 plus our 28 plus our 5, right? And we're again going to put that number over our 300, okay? I'm going to show you all an easier way to do this too, just like I did a minute ago, but I want to show you all this one first, okay? Now, here's my question. How many were in both the color and the song? Can anyone tell me what 2 numbers represent both?
28 and 5.
There you go. So that's what we're going to subtract. So we're going to do our 28 plus our 5, and we're going to put that over our 300 as well, okay? So now, y'all want me to show you the easy way to do this? Yes? You should say yes here, y'all. This is all you have to do. The easy way to do this is literally add up all the numbers that are in the color and the song and put them over 300. Okay, so do y'all see what I'm saying? So literally, to do that the easy way, all I'm going to do is I'm going to take all these numbers. I'm going to take the 35 plus the 58 plus the 28 plus the 5 plus the 31 plus the 10. Now, have I represented all the numbers that are up here in this circle and down here? Yes, I have. And I put those over the 300. That's the easy way to do an or problem, okay? Now let's talk about and, okay? So now if I was to ask you, we're going to change, all we're going to change of this problem now is the symbol. Y'all see this up here? All we're going to do is change the symbol. So when I change the symbol, Let me go ahead and change this to an and symbol. We're going to go up here and change it to the and symbol. There it is. Okay. So now all we're looking for is the overlap. Y'all see that? So what is the overlap between colors and song? Someone tell me.
5 and 28.
There you go. So all we have to do now is do the 5 plus the 28 and put it over what number? Sorry, that should have been plus, y'all. What am I going to put it over? What was the total, y'all?
300.
The 300. And that's how I get the and. So let's talk about some different options. What if I said mascot and song? Then we're going to add the 5 plus the 31 and put it over the 300. What if I said mascot and colors? Then we're going to put the 5 and the 58 and the 5 over 300. So all we're looking for when we're talking about and statements, y'all, is the overlap. Okay, that's it. So you're going to put whatever the overlap is over the total. When we're talking about or statements, we're talking about everything that's in both circles, okay? So does that help you guys?
Yes.
All right, I got one more thing I want to say to y'all. On the quiz, you had a question that said nor and neither. Okay, so if I tell y'all I am not going to the prom, nor am I going to the concert. What does that mean?
You're not going to either one of those
I
places.
didn't go to, I went to neither. Y'all got me? So that means if I told y'all the probability of me going to prom was 50% and the probability of me going to the concert was 30%. What is 50 plus 30?
80.
80. So what's the probability that I went to neither then?
20.
20. Do y'all hear what I'm saying? That's that neither nor question. You find the probability of or and then subtract it from 1. Isn't that what y'all just did?
Mm-hmm.
Do y'all see what I'm saying? That's all you have to do for that problem that said neither nor, is find the or probability and then subtract it from 1. Is there a problem I can do? Okay, so let's go back up here. Someone's asking about cards. So let's talk about red and black. That would be 100%, wouldn't it, y'all? Well, actually, this wouldn't be red. This wouldn't be. Draw one card, keep it, and draw another. That's the key with these. Y'all see this? On the first one, we pick only one card at a time. So what does that mean? This one's going to be independent. Y'all see this? Or actually, this is an or statement. My bad. This is going to be mutually exclusive or inclusive. This one's going to be and, which means it's going to be independent or dependent, okay? So is there any overlap between a queen and a 6?
No.
Okay, so that would be what? Mutually exclusive. Is there any overlap between red and black?
No.
Okay, so that would be mutually exclusive. Is there any overlap between a face and a king?
Yes.
Yes, so this would be inclusive. Y'all got me there? Okay, let's go down here to this one because I've totally run out of time, y'all. But we're going to do this. Now, this one's an and statement. So it says, draw one card, keep it, and draw another. So are these probabilities going to be dependent or independent?
Dependent?
Dependent. Now, if we put it back, it would be independent, wouldn't it, y'all?
Yeah.
But all of these are going to be dependent, which means sometimes both the top number and the bottom number is going to change. Now, if y'all want a little more comprehensive understanding of what we just talked about, then what you guys need to do is you need to go and watch that Zoom video that I did that talked about the activity and the 11, 2, 3. And it's on my e-class, and I think all the teachers have created some way for y'all to see those Zoom videos because they're posted on my YouTube channel. So any parting questions y'all have for me? Anybody?
What if you're like trying to figure out like the percentage of not doing anything?
Then you find the percentage of doing it and you subtract it from 1.
Okay.
Okay?
When we have a problem that says A and then there's like a vertical line and then it shows a B, what is that vertical
That
line?
means if what happened first, so basically you're talking about, let me see if I can show you here. You're talking about something when it's given, right? That's what that slash means. What is a probability that A occurred given that B occurred. That's what you're asking about. And again,
Okay.
if you will go watch that video, that Zoom video I created, I went over that as well. Okay.
Okay.
And I'm only saying that because I have to stop, y'all, because I'm going to get in trouble because I'm only allowed to go till 10:30. So if y'all
Okay.
have other questions, go ahead and email them to your teachers, okay? And see if they can
Okay.
assist you. Send them to them through Remind or send them to them through their email, okay?
Hey, for my kids, can I talk for a second, Ms.
Yeah,
Jones?
go ahead.
There's also a folder on my e-class under content that's called probability videos.
Mine
That
too.
has more videos too. Yeah, so I think it's on everybody's. So there's a probabilities video folder, and there's a lot more videos of just some other ways of doing some problems. It's the same stuff, but just more examples. So if you want to use that, that's also there too. So that's a good resource.
Okay.
All right, y'all good?
Yes.
So you guys have till Thursday at 11:59 to finish, to do your second, basically try on that quiz, okay? And hopefully
Right.
today helped you. And if you guys will watch those other Zoom videos, I promise you guys, if you will watch them, they will help you, okay?
Okay.
Okay.
All right, y'all have a good day.
All right. Bye.
You
Thank
too.
you.
You're welcome.